Hi, this is Zach Beckstrom again with Chapter 4.3, Cylinders and Spheres. With this section, we'll be looking at the areas, both surface and total areas, and volumes of cylinders and spheres. So let's first talk about a cylinder. A cylinder is a solid object with two identical circular bases. You can see both of these are cylinders. A right cylinder is when the sides of it are perpendicular to the base, as you see in this first cylinder here. And a non-right cylinder or an oblique cylinder is one where the sides are not perpendicular to the base. They do not meet at a 90-degree angle. Alright, so let's look at a couple of formulas here. We'll have the lateral surface area. This is the surface area around the sides of this cylinder. Think of a can of Coke, and this would be the area around the side of the can where you see the lettering. It would not include the top or the bottom. And then we can also look at the total surface area. That's the area around the side and the top and the bottom. And remember, the two bases are both identical, so we can just write that as 2 times the area of the bases. And then we can look at the volume, which is the area of the base times the height of the cylinder. We can also come up with an approximation, which is this 0.7854, the diameter squared times the height. Or we can do in terms of the diameter, which is 1/4 pi times the diameter squared times the height. And you can see that the big C is the circumference of the base, h is the height or the altitude you'll commonly see, the big A is the area of the base, the little r is the radius, and little d is the diameter. So example 1, let's find the lateral surface area, total surface area, and volume of this right cylinder. So the only information that it gives us now is the altitude or height, which is 12 meters, and the radius of the base, which is 4 meters. Okay, so the solution is, if we're doing the lateral surface area, we can use any of the formulas, but let's use the 2 pi r h. We probably use this formula because it gave us the cylinder in terms of the radius. If it would have given it in terms of the diameter, we could have just divided that diameter by 2, or we could have used the formula that included the diameter, which was the pi d times the h. So we plug in our values, 2 pi times the radius, which is 4, times the height, which is 12, which gives us 96 pi, or approximately, rounding to 2 decimal places, 301.59 meters squared. With the total surface area, we're just taking that lateral surface area, which is the surface area around the cylinder, and we're adding both the bottom area and the top area, which we can just write as 2a, which is 2 times the surface, or not the surface, excuse me, the area of the base. So we already know that the lateral surface area is 96 pi. We can easily find the area of one of the bases by pi r squared, which is 16 pi, and then we multiply that by 2 because we have 2 bases, and we get a total surface area of 128 pi, which is approximately 402.12 meters squared surface area. And then remember, this is rounded to 2 decimal places. And finally, the volume. Let's go ahead and use this formula here. It's not ideal considering that they gave us the radius, but I wanted to give an example where we had to do a conversion before we could solve it. So this formula here is 1/4 times pi times our diameter squared times the height. So we plug our values in. Remember, it gave us the radius, so we need to convert that radius to a diameter, and remember that the diameter is twice the radius. So we plug an 8 in there. And then we multiply that by the height, which is 12, which, if we remember to do our order of operations, we'll do that exponent first and then the multiplication. We should get 192 pi, which is approximately 603.19 meters cubed. And don't forget, when we're talking about volume, it's in the cubed term, and we're talking about areas, it'll be in the squared terms. Alright, so let's take a look at the sphere. Sphere is defined as the surface whose points are all equidistant from a given point called the center. So if I took a point, any point in three-dimensional space, and I looked at every point that was the same distance away, let's say 1 foot, it would create a sphere. That would be all the points that were exactly 1 foot away from my given point called the center. So the formula for the surface area, you remember, we're not going to distinguish here between the lateral surface area and the total surface area because we don't have any bases on a sphere. It's one circular surface there. So the surface area is going to be 4 pi r squared or pi d squared. Either one of those, depending. We usually use whichever value they give us in the problem, and the volume is 4 pi r cubed over 3 or pi d cubed over 6. And remember, we can also convert. The nice thing about spheres is we really only have to have one measurement, which is that either radius or diameter, and we can figure out pretty much everything from that one number. So let's look at an example here. Find the surface area and volume of the following sphere with a radius of 6 inches. So go ahead and try that one. You can pause the video. When you come back, we'll see how you did. Alright, so hopefully with the surface area we used the formula that had the radius in it, which we just plugged that 6 in there. So that's 4 pi 6 squared. Remember, we have to square that 6 first, so 36 times 4, 144 pi, which is approximately 452.39 inches squared. And then with the volume, we'll use the formula here, the 4 pi r cubed over 3. Plugging in our values, we get 288 pi, or approximately 904.78 inches cubed. Alright, well, thank you, and make sure to email me any questions you have or give me a call, and have a great rest of the week. Thank you.